exponents in equations. It's called exponential growth. I told you at the beginning of this semester that we would be using exponents for the rest of the year. So today we're going to learn how to use them in equations and how to write functions with exponents. Let's look at the difference though between linear and exponential functions. We've been doing linear for a long time. When we had linear functions, we know that the y value always increased by the same amount. So we had what we called a common difference, or a common sum. For an exponential function, the y values are going to be multiplied by a common factor. That's the way you tell it's exponential. The y values are multiplied by a common factor to get to the next y value. If it's linear, it's added or subtracted to something. If it's exponential, it's multiplied by something. Do you understand the difference? Linear, adding or subtracting the same number. Exponential, multiplying by the same number in the y value. Are we good so far?
Yes.
Great. Take this set of data. X is negative 2, y is 5 over 4. X is negative 1, y is 5 over 2. X is 0, y is 5. X is 1, y is 10. X is 2, y is 20. And we're going to come up with the rule or the function for this set of data. There are 3 steps that we need to take. Step 1 says determine if the function is exponential. How do I determine if it's exponential?
If it's time.
Okay. I'm going to start with the 5 because I don't like those fractions. How do I get from 5 to 10? Times 2. How do I get from 10 to 20?
Times 2.
Times 2. So now let's go back and see. How do I get from 5 over 2 to 5? Times 2. Because 5 over 2 times 2 over 1, the 2's cancel out, I'm left with 5 over 1. 5. How do I get from 5 over 4 to 5 over 2? Times 2. Because 5 over 4 times 2 is 10 over 4, which reduces to 5 over 2. Okay? So is this exponential? Yes, it is. The y values are being multiplied by 2 for each increase of 1 in the x. So using the equation y equals a times b to the x, where b equals 2. So up here next to our graph, next to that, all of those times 2's, I want you to put that's what b equals. Are you with me so far? Circle y equals ab to the x. That's the parent function. We found b. Now we're going to find a. A is relatively simple to find. A is the y value when x equals 0. When x equals 0 in our chart, what is y?
5.
5. X is 0, y is 5. So the value of y when x is 0 is 5. So a equals 5.
Can you pull it down?
So sorry. So now we're going to plug in a and b to this y equals ab to the x to write our function. So y equals, what is a?
5.
What is b? To the x power. So now our x is an exponent in an exponential function.
Yes, sir.
So to find b, once again, I go back up here and look at how, let's graph my, I apologize, these graphs are small, but we're still going to graph it the best way we can. Negative 2 and 5 over 4. What is 5 over 4?
1 and 1/5.
1 and 1/4. So we go to negative 2 up to 1 and 1/4. Negative 1 and what?
2.
2 and 1 half.
2.5. Negative 1 and 2.5. 0 and 5. 1 and 10. Well, I can't graph it. Okay? Let's go back one just so we can see this a little more. When x is negative 3, what is 2 to the negative third power?
1 over
6.
1 over
1 over 8. 5 times 1 over 8 is 5/8. So let's graph that. Negative 3 and 5/8. And now you see we have a curve. With the linear function, what did we get when we graphed it?
Straight line.
A straight line. With an exponential function, we get a curve. We good? Now let's talk about this curve. This curve is never going to touch the x-axis. Okay? I'm going to tell you that again, just so that you know. It is never going to touch the x-axis. Because there is not a way to create an exponent so that the y equals 0. In the function y equals ab to the x, there's no exponent that I can find to make y equal 0. Okay? So it'll never touch the x-axis. So let's talk about the domain. Looking at this table of values, what is the domain?
negative 2 to 2. It can be any of them.
But it keeps going. So what are all those?
Negative 2, negative 1, 0.
What do we call those?
All
What?
numbers.
All real numbers.
Real.
So the domain is all real numbers. There are some positives, there are some negatives, so it's all real numbers. Look at the range. The range. What is the range? Remember I told you it never touches the x-axis. So what is the range going to be?
All positive numbers.
All positive real numbers. All positive real numbers. Yes, Jared?
So will the range always be all real positive numbers?
In the equation where a and b are positive, yes.